Approximately 74,000 years ago, the Toba Supereruption on the island of Sumatra, modern-day Indonesia, expelled an enormous volume of volcanic material, depositing ash globally and influencing climate in regions as far afield as Africa. Earlier hypotheses posited that this event triggered a volcanic winter so severe as to drastically reduce or even nearly extinguish human populations. Recent archaeological, geochemical, and paleoenvironmental evidence, however, suggests a more nuanced scenario. Rather than near extinction, human populations, specifically early Homo sapiens in Africa, exhibited resilience, adaptation, and possible technical innovation in response to environmental stress. This article synthesizes current findings, outlines the nature and scale of the eruption, examines climate and ecological impacts, evaluates the human survival/innovation record, and outlines remaining uncertainties and future research directions. Supervolcanoes represent among the most extreme natural hazards in Earth's history. By definition, a supereruption involves ejection of more than 1,000 km superscript 3 of rock, ash, and debris. The Toba event, often referred to as the youngest Toba eruption, is the most recent major supereruption at that site. Although no human populations are known to have been living close to the eruption's caldera in Sumatra, ash and tephra from the event reached distant regions such as southern and eastern Africa. The Toba Supervolcano on Sumatra released vast volumes of material. Its caldera today hosts Lake Toba. Because the eruption is so ancient, 74 Ka, direct measurement of volumes and ash dispersal rely on tephrochronology and geochemical proxies. One key proxy is cryptotephra, microscopic glass shards, typically 20-50 m in diameter, that can be found in sedimentary layers far from the eruption site. The identification of such cryptotephra in African archaeological sediment layers enabled precise correlation of human site stratigraphy with the timing of the Toba eruption. Early work argued that the Toba eruption could have triggered a volcanic winter, a prolonged period of extreme cooling and reduced photosynthesis, possibly leading to near extinction of human populations. More recent investigations have refined this picture. In an Ethiopian site, paleoenvironmental evidence indicates that post-eruption climate became more arid. Rivers dried up into smaller waterholes, changing ecological conditions. However, evidence for large temperature drops or long-term global glaciation remains lacking. Indeed, researchers now argue that in Africa the human populations did not approach extinction as previous hypotheses suggested. Archaeological sites in southern and eastern Africa provide evidence that early Homo sapiens survived, and indeed, adapted, through the period of and following the Toba eruption.